Hello, class. Let's talk about the solar system. So, what do we know about the solar system? Well, here's the basics. The solar system is 4.6 billion years old. We know that from looking at the oldest things in the solar system, which are asteroids, and doing radioactive dating on those, mostly uranium dating. Also, looking at the stage of our sun in its life cycle, we can compare that to other stars, and that's where we get kind of a confirmation. There are 8 planets. There are 2 asteroid belts. A lot of people know about the one between Mars and Jupiter, but not many people know that there's actually a second one called the Kuiper Belt that's outside of Neptune's orbit. There's obviously one star, but there are lots of systems that have binary or trinary or even more stars in the system. And there are 5 current dwarf planets, Pluto being the most notable one, although it should be mentioned that it is not the largest one. Eris is actually the largest one. So what are the observations we have of the solar system? So if we're going to find an origin of the solar system and how it started, we need to match the observations. So the things we observe is that everything is rotating pretty much universally counterclockwise. That's both revolution around the sun as well as rotation of the planets. Although there's a couple planets and a couple moons, Uranus is the best example, that don't rotate the way we'd expect. Part of that's because Uranus is weird and is actually on its side, which is kind of bizarre. Nearly everything lies in a flat plane, which is called the ecliptic. So if you think about the solar system, it's basically flat like a sheet of paper. Nearly everything follows almost circular orbits. They're called elliptical orbits because they're not perfectly circular, but they're 99% circular, with the exception of a couple of things. Pluto is a good exception. That's why part of the reason why it's not a planet anymore is because Pluto actually sometimes is inside Neptune's orbit. When I was really little, when some of your parents were little, chances are for part of that time, Pluto was actually inside Neptune's orbit. It doesn't happen very often, but it happens for about 75 years or so at a time. Comets also have very eccentric orbits. They do not follow circular orbits, but again, they're from kind of outside of what we consider the standard solar system. As far as the composition, basically inside of the asteroid belt is very rocky. Between the asteroid belt and the Kuiper Belt is mostly gaseous with some rocky stuff in there too, but those are mostly asteroids, moons. And then outside of the Kuiper Belt and in the Kuiper Belt are all icy objects like icy planets or icy dwarf planets like Pluto, as well as comets. So how can we explain these observations? Well, when we know that as objects collapse, they start to rotate. And so if the gravitational collapse of our solar system cloud of dust and gas began, then everything inside of that cloud, eventually asteroids and planets and all those things, the sun, would all rotate in the same direction. As those things rotate, they would start to thin out, kind of like if you think about spinning something above your head. As you spin it faster and faster, it stretches out and thins out into a nice flat plane so that it follows basically a flat disk as you spin it around. As those objects thin out, way to go, me. They do so uniformly. In other words, they thin out in all directions equally. They don't thin out in some directions more than others. That would make more of an oval as opposed to a fairly circular orbit that we see. And because of the heat of the sun, things really in close need to be able to survive that intense temperatures, and that's mostly rocky and metallic objects close to the sun. Further out, gases can actually condense, but you have to go very far out before you get to ices and other solids of that nature. And here's kind of a visual of that. I'll put this PowerPoint on Schoology so you can see it. So, what started all this? Well, a supernova would have erupted, and when that happened, the pressure of the supernova pushing out would have hit our solar system dust cloud, and that nebula, our nebula of our solar system, would have collapsed because of that pressure. Basically, gravity would have won out over the balance and the pressure that always kind of exists between objects. One thing I want to talk about really quick is the cause of seasons. So seasons are caused by the Earth's tilt. The sun has more direct contact with the northern hemisphere in the summer, and in the southern hemisphere, it's less indirect contact. So while we're in summer, the southern hemisphere is in winter. If you were to move this to the other side of the sun, that would be winter for us. It would be indirect sunlight here and more direct sunlight in the southern hemisphere. Fall and spring are basically the same season. One's just going towards winter and one's going towards summer. Otherwise, they're basically the same. Something that's interesting to note is that the seasons aren't actually all the same length. Summer is actually about 4 days longer than what the winter is. And the reason for that is that the summer occurs when the Earth is further away from the sun. Most people think that summer happens when the Earth is closest to the sun. The Earth is slightly further away from the sun in the summer, and because it's further away, it actually travels a little bit slower. So it takes a little bit longer to travel the summer portion of its orbit than it does to do the winter portion. So the summer is actually 4 days about longer in the northern hemisphere in the southern hemisphere. So just think about that if you consider moving to Australia. Summer is actually about 4 days shorter. So something to think about. Okay, so for this last bit, I want to talk about the moon and why the moon matters and some origins for the moon. I apologize in advance. My brother has begged me to do this. So we'll see how this goes. Well, hello, friends. It's your good pal Eeyore. I wanted to talk to you about the moon. Not that you'll understand it, because I'm terrible at explaining things like everything else. Well, I might as well try anyway. There's 4 theories. Sister theory is that the moon formed at the same time as the Earth. But that's not that likely because they have different composition of materials than you would expect. Capture theory is that the moon was caught in Earth's gravity, but that also seems unlikely because the moon is really big and moving too fast for Earth's gravity to have caught it in the first place. Daughter theory sounds sweet, but it's not likely either because it would have to have broken off of the Earth, and we would have seen more similar compositions if that were the case. So the most likely theory is impact theory. Basically, something the size of Mars crashed into the Earth and smashed, and then formed the moon from the leftover debris. That way some of the materials would match, but not all of them. It also explains the speed and how Earth could have caught it in its gravity. What it doesn't answer is where it came from. For the most part, the solar system is pretty thinned out, and the objects are far away from each other. We haven't seen anything else like this very much in the solar system, except some of the big moons of Jupiter, maybe. So, why does the moon matter? Well, the moon is actually quite responsible for life on Earth. The moon is very large, as Eeyore mentioned. In fact, so large that it has a kind of impact on the Earth that no other moon seems to have on its respective planet. It causes and affects tides, which affects weather, as well as the life cycle of plants and animals in those oceanic regions. It also might be part of the reason the Earth's core is believed to be a molten liquid. And if that is part of the reason, kind of rubs on the Earth, sort of like rubbing Play-Doh around in your hands. And if that's the case, that is what causes Earth's magnetic field, possibly. So the moon being so large and close to the Earth might be the reason the Earth's magnetic field exists, which is part of what keeps all the radioactive particles from the sun from killing all life off on Earth. So the moon is actually quite important to life being on Earth, which is pretty interesting considering that it's really out of place in the solar system, part of what makes Earth so special. So hopefully Eeyore and I were able to teach you a couple of things. And if you have any questions, let me know. I'll include a couple of videos for you to look at, and you can make some comments on the discussions. Have a blessed day. Goodbye.